Breakthrough tech recovers 92% of EV battery metals. Sustainable future. What if the key to a cleaner future lies in the very batteries we throw away? Imagine a world where the materials from your old smartphone or electric car battery could be reborn into cutting-edge technology, slashing waste and saving the planet. But here's where it gets controversial. While one administration pushes for greener policies, another scraps them, leaving the energy sector in a tug-of-war over sustainability. And this is the part most people miss. Even as we champion renewable energy, the hidden crisis of battery waste is growing, threatening to undermine our progress. Let's dive into how a groundbreaking recycling method might turn this around, and why it's sparking heated debates about the future of clean tech. Lithium-ion batteries power everything from our phones to electric vehicles and even smart grids. They're a marvel of modern engineering, offering unmatched energy density and scalability. But there's a catch. These batteries degrade over time. After thousands of charge cycles, they become useless. What's left? Valuable metals like nickel, cobalt, and manganese, materials that are costly to mine and devastating to the environment. Without a smarter recycling strategy, the clean energy revolution could backfire, creating a mountain of toxic waste. Traditional recycling methods fall short. They're energy hungry, pollute the air, and often leave metals in a state too degraded to reuse. That's why scientists at Worcester Polytechnic Institute, WPI, are rewriting the rules. Their new hydrometallurgical process isn't just recycling, it's upcycling. By transforming old battery components into high-performance materials for next-gen batteries, they're closing the loop with 92.31% material recovery. Think of it as a rebirth for batteries, turning worn-out cathodes into advanced 83Ni materials that outperform their predecessors. The results? Recycled batteries retain 88% of their capacity after 500 cycles, and 85% after 900 cycles in commercial-grain cells, all while using 8.6% less energy and cutting carbon emissions by 13.9%. That's not just eco-friendly, it's a game-changer. Professor Yan Wang, the mastermind behind this innovation, isn't just publishing papers. As co-founder of Ascend Elements, she's already commercializing this tech. So, while some might argue that recycled batteries can't match new ones, this method proves otherwise. The recycled cathodes don't just recover materials, they regenerate them with next-gen chemistry, aligning perfectly with today's electric vehicles and solar storage systems. But here's the kicker. This isn't just about technology. It's about reshaping supply chains. By reducing reliance on mining, we cut costs by 76%, curb environmental damage, and build resilience against global resource shocks. And for you, every time you charge your phone or drive an EV, you're part of this shift. Imagine your devices powered by materials reborn from discarded batteries. Sustainable, affordable, and high-performing. This isn't science fiction, it's the future being built today. So what's your take? Should we trust recycled batteries to power our cars and homes? Or do we still cling to the myth that new is always better? Let us know at cyberguy.com/contact. And don't miss out on the latest in tech and sustainability. Sign up for my free CyberGuy report for expert insights, security alerts, and exclusive deals. Together, we're redefining what's possible for a cleaner, smarter world. Circular solutions for EV battery waste in Asia Pacific. Transforming EV battery waste into circular solutions in Asia and the Pacific. The Asia-Pacific region is emerging as a leader in innovative solutions. With the rapid adoption of electric vehicles, EVs, this area faces a significant challenge: how to effectively manage the environmental and health hazards posed by end-of-life EV batteries. while simultaneously seizing the economic and technological prospects offered by a circular economy. By effectively merging public policy with private sector creativity, particularly among micro, small, and medium-sized enterprises, MSMEs, the region can convert this challenge into a model for inclusive and sustainable economic development, embracing the circular economy, a necessity for change. The shift towards electric vehicles is not just about achieving cleaner transportation and energy solutions. It represents a profound transformation in our approach to utilizing, recovering, and repurposing resources. The concept of a circular economy, founded on the principles of reduce, reuse, recycle, repurpose, and recover, offers a strategic framework aimed at maximizing the value of battery materials, reducing waste, and breaking the connection between economic growth and climate change. These principles are vital for effective battery waste management. However, achieving this ambitious goal requires more than just technological advancements. It necessitates the development of a skilled workforce and the creation of innovative business models. Therefore, education and capacity building are essential components. Without a comprehensive understanding of the specific contexts within countries and the practical application of circularity principles, the vision of a truly sustainable ecosystem will remain unfulfilled by 2030. The Jaipur Declaration on 3R and Circular Economy, established in 2025, provided essential insights and solutions for transitioning towards circularity in the management of end-of-life batteries and vehicles, harmonizing policy frameworks, national, regional, and global goals. Tackling the issue of EV battery waste requires a collaborative effort. No single nation can address it in isolation. Governments play a crucial role in creating strong regulatory frameworks, such as extended producer responsibility, EPR schemes, mandatory recycling targets, and eco-design standards. These policies must be in harmony with international climate agreements, such as those established at COP29 in Azerbaijan in 2024. Such global dialogues highlight both ambitious emissions reduction goals and the essential role of circular economy principles in achieving net zero emissions. By legally formalizing these requirements and linking them to transparent reporting and monitoring, governments can ensure that localized initiatives contribute effectively to broader climate and sustainability objectives. Creating synergies, circularity, finance, and multi-stakeholder engagement. The transition to a circular economy for EV batteries is most successful when driven by collaborative synergies. At its core, this synergy involves the integration of circularity principles, innovative financial strategies, and multi-stakeholder dialogues. These discussions should include government agencies, leaders from the private sector, MSMEs, civil society, and academic institutions. Circularity encompasses more than just recycling. It requires a fundamental rethinking of the entire value chain. National and regional collaborations are essential for sharing best practices, standardizing processes, and coordinating the cross-border movement of recyclable materials. These collaborative platforms are vital for enhancing advanced recycling infrastructure, promoting eco-design, and embedding circular economy principles throughout the product lifecycle, from design to end-of-life management. Financial innovation is equally important, necessitating the integration of digital technologies and innovative policies to encourage widespread investment in digital public goods and infrastructure across various sectors. National governments, often in partnership with regional and international development agencies and financial institutions, can play a crucial role. They can offer grants, concessional loans, and investment guarantees to reduce barriers for MSMEs and startups entering the battery recycling and repurposing market. By combining financial support with technical training and capacity building initiatives, these programs empower local businesses to foster innovation, create green jobs, and strengthen regional supply chains. Empowering MSMEs through education. The SCAP Sustainable Business Network, ESBN, position paper on the circular economy emphasizes the critical importance of education in bridging the gap between policy and practice. Comprehensive public awareness campaigns are essential for promoting responsible disposal of EV batteries and educating communities about the risks associated with unsafe, informal practices. Additionally, targeted capacity building and technical training for MSMEs, technicians, and recyclers are crucial for developing the expertise necessary to safely manage, process, and innovate with battery waste, ensuring that local practices align with international standards. The recent 4th International Conference on Financing for Development also highlighted the urgent need for appropriate incentives, particularly those that support MSMEs. Looking forward, a roadmap for a low-carbon future in the region. The Asia-Pacific region stands at a pivotal moment, with a unique opportunity to enhance its knowledge-sharing and capacity-building efforts in circular economy innovation. SCAP is prepared to assist in this critical transition. This endeavor goes beyond mere waste management. It involves rethinking the value of a circular economy, creating green jobs, enhancing education, and fostering innovation that benefits both people and the planet, a vision highlighted in a recent SCAP policy document. It is essential to seamlessly integrate national policies with regional frameworks and global commitments. Additionally, deploying smart development financing tools, digital technologies, and fostering synergistic public-private partnerships are crucial. With the right strategies in place, the Asia-Pacific region can transform the challenge of EV battery waste into a significant opportunity for inclusive and sustainable economic growth, new job creation, and improved climate resilience. California could slash 56 million tons of CO2 emissions by reusing EV batteries. Prepare for a game-changing pivot in the EV ecosystem. While many cling to the recycle-first mentality, a fresh study reveals California could cut 56 million tons of CO2 by upcycling retired electric vehicle batteries before sending them to the scrap heap. This bold strategy could become a blueprint for sustainable energy grids beyond the Golden State. Let's unpack how this works and why timing is everything. Here's the climate perk. Reuse before recycle. An international research collaboration has crunched the numbers, and the verdict is clear. Repurposing EV batteries as grid storage doubles carbon savings compared to immediate recycling. Why? Manufacturing new batteries is a carbon-heavy process. Slowing their replacement by using retired vehicles and stationary storage, like solar, wind firming, delays this carbon footprint, buying time for greener battery production methods to develop. The surplus problem. Second life batteries will overwhelm demand. By 2050, California could see an avalanche of spent EV batteries. Studies' projections show even focusing solely on safest, longest-lasting battery chemistries, like lithium iron phosphate, would still create a glut of reusable packs. Utilities would struggle to absorb this wave, making robust recycling infrastructure essential, even if reuse is prioritized. 3 scenarios. Trade-offs illuminated. 1. Current status quo, 2.5% repurposing. Just a fraction of batteries get a second life. Most go straight to recyclers. Carbon savings, 48 million tons. 2. Full recycling. Every battery dismantled immediately. Carbon impact still saves metal recovery costs, but misses the emission-delaying second life phase. 3. Max the use first. Batteries as storage until electricity grids are saturated. Eco-win. Jumps to 56 million tons saved. Why this matters for U.S. energy policy. With federal EV incentives accelerating both car sales and renewable energy buildouts, states adopting California's circular battery strategy could stabilize grids, Provide low-cost energy storage for solar wind. Reduce mining reliance. Keep critical metals, lithium, cobalt, in active use longer. Prevent waste. Avoid premature battery landfilling during charging infrastructure ramp-ups. Controversy alert. Green versus circular priorities. Should environmentalists push for immediate recycling to eliminate battery waste earlier? Or is engineering a use-first economy more sustainable? The study forces a tough question. When does the pursuit of efficiency clash with the need for immediate environmental action? Of action items, what experts urge? Policymakers must invest today in collection systems, creating networks to gather used batteries, a la smartphone buyback programs, disassembly tech, automating battery extraction to streamline recycling later. The era of battery retirement is here. Will we treat these energy reserves as transitional assets or instant waste? Share your take in the comments. Should governments incentivize reuse first or prioritize closing recycling loops fast?